Hey, what's up guys? I am Joe from Workbench.
I'm Seb for Workbench, and today we're going to talk about making a Tron-style 3D effect.
Like Stu Maschwitz did in his recent short film, Tank. So if you've been following us on Twitter, or maybe you saw us on our new Twitch channel, Failbench, we started recreating that look that Stu Maschwitz got in his short film, Tank, using a different setup. He made this by manually placing nulls on every corner, basically building this entire thing in After Effects, and used the beam effect to link everything together. That's a super intensive way to build it, but this isn't knocking that at all. For one thing, I'm actually a huge fan of doing something that's really intensive to get an interesting result that pretty much nobody else would do. There's just something about that that makes it really special in the end. And Tank itself is really special. I'm going to leave a link down below for you to check that out, because you should. And then you should watch the BTS, because that makes it even more amazing if you don't understand what's going on. And there's a lot of really neat ideas in there. But we're going to be building this in a different way. This technique didn't even actually exist when Stu started working on Tank. I think he actually even finished it before this was available. So let's jump into 3D with Sev and get started on this.
In order for this effect to work, we need to have null objects on each of the vertices, and then export those into After Effects so that we have 3D data for this effect to work. The easiest way to do that is to use the cloner system. So essentially we take a cloner and we grab a null object. We make the null object a child of the cloner, and then we take the cloner and set it into object mode. And then we're going to take the tank and put that as our object. I'm going to hide the tank so you can take a look at what's going on here. So you see I have a null object at every single vertice. The next step is very important, because if you don't do it, when you take the cloner and convert it into separate objects, well, let me show you. It just joins it all up as one. Not what we want. So you grab your null, and then you're going to add external compositing to it. And this is so that Cinema knows that you want to export this into After Effects. So then you grab the cloner, and you can either hit the C key or right click and go make editable. And then you also want to take the cloner and give it an external compositing tag. So then the only thing that's left is to save the file and open it up in After Effects.
Then when you come back into After Effects, you'll just make a new comp. Doesn't really matter what we're going to name it at this point. I'm going to bring this tank in. You can actually import C4D files directly into After Effects now. And then our Cineware effect, we're going to go down to the bottom, hit extract. That's going to get all the nulls and the cameras and stuff out of this scene. Then we're going to dump the C4D file out of here, and the camera, because we don't really need that. And we're going to take this cloner null, move it to the bottom. If you notice, our nulls start with 0 and our index starts with 1. There is a way to renumber these in Cinema, but it's easy to just add 1 to our null number to get the one that we're looking for. That'll be important in our expressions later. So I'm going to select all of these. I'm going to hit A to bring up the anchor point. I'm going to hit 0, tab 0, enter, so that we zero them all out and put the anchor point to the top corner. That'll make sure that our lines end up in the right place. Then I'm going to hit R, and on the X rotation, I'm going to click that. I'm going to hit 0. I'm going to tab twice, 0, tab twice, 0, hit enter. Not sure why that one didn't change for some reason. Maybe because that one didn't have any. That must be why. That must have been 0 to begin with, so it didn't change any of them. There we go. So make sure they're all set to 0. Then I'm going to hit R to close that back up, and I'm going to deselect the cloner at the bottom and then parent all of these guys to the cloner. Then I'm going to click our cloner. I'm going to hit P. I'm going to set it to the center of our comp, which is 960/540. And then you can see it's a little bit more tank-like. If I actually rotate this thing around, you can kind of see how it would lay out. So those nulls are in the top of every one of our comps. We don't need any other copies of that right now, so let's dump these out. So using Cyclops by Kyle Martinez, we can get a representation of how this is built. Instead of using Beam here, we're using Video Copilot's Saber, but I'm also going to show you a way to make that with shape layers themselves. So let's jump into Cinema to figure out what nulls go with what polygons. All right, so in this tutorial, we're going to have some data that we need out of our 3D model. So once we've brought all the nulls in, we need to reference them in an order so we have polygons to work with. So the easiest way I've found to do that is just take note of their number as we go around the surface that they're supposed to be on. Because later on we're going to be dealing with normal calculations, you want these to go in the same order. I like to pick clockwise while I'm doing it. So let's say we're doing this top polygon right here. So we'll be picking this null, and then we scroll down here and we see that's 34. Then we'd pick this null, that's 32. And then we'd pick this null. Should have to actually get it right in object mode. That's 28. And you just keep going around the shape like that. This top piece is a little special though. I don't want this line to actually show up. So keeping that in mind, I actually want to start with this null back here. So we're going to keep going around clockwise. So that's going to be 27, and that is 11. That one's 22, 34, 32, and then 28. So those will be the nulls that define this polygon. So what I just did was write that down in some field notes, and I did that for every polygon in this thing. So when you come back into After Effects, you have all of that null data ready to go. That's going to be using different expressions and things throughout this tutorial, but mostly those strings of numbers are going to be used to rename a slider control that we'll reference in an expression later. So I'm going to take you through the process of how we built this, but I'm only going to explain the expressions and stuff used in the best version of this. So this first version is basically just the initial idea. It's just all the nulls linked up in a bunch of masks on one layer that has Saber. But because of that, that means we can't get any of the cool semi-transparent lines that are supposed to be like the back faces of the 3D object. So then I figured out how to do that. So that's what we have here. You can see this back piece is faded in here. The side piece is faded. All the pieces facing away from us are more transparent. Unfortunately, that means that each one of these polys is on a new layer with a new copy of the Saber effect, which really slows it down. But it looks so good, so if you want it to be this way, you're just going to have to take the render hit. But if you need to animate it and you don't mind setting up two different versions, you can basically combine that first version where there's not really any normals, animate using that, and then render with a version that has normals like this. I was building some of this on my stream, and Andrew Embry came by and asked if maybe solids would be faster than the shape layers I was using for this thing. Because shape layers can kind of be an infinite size, we were thinking that the calculations involved in dealing with that might actually slow it down a little bit. And surprisingly, it actually turns out that solids are slower, at least on my machine. You can test it on your own machine if you want, because I'm going to leave all of these things in the project file. It's not a huge difference, but over about 100 frames, it's about 10 seconds. It turns out that AE must have some sort of optimizations for shapes, so I'm thinking that maybe the bounding box of the shape layers is only exactly as big as you need. So far, all of these versions have a problem. I'm using a list of each null to build a poly. Let me just take a quick look at this expression here. So if we open up Expressionist, and we make it bigger, let me grab this guy in here. I'm not going to go over this whole thing, but I want you to see that here we have all the points that make up this plane. So it's null 36, 11, 27, and so on. In our opacity, we're doing the same thing to figure out the normals. And the problem with that is that because all of these expressions contain this data, I can't make a change in one without having to manually go into each one of these and change it. I wanted to be able to change this opacity expression and then copy it to all the other ones using copy expression only. So I started to experiment with that. So what I would have liked here would have been some sort of control that lets me put a string someplace. And if I knew how to build one, I would make one that was keyframeable, because that would be really nice. So instead, you can see I put all the data in here in slider controls, that I could loop through all of these and get all the points for each one of these things. So both my mask path and my opacity could reference the same data. But this is also really annoying to set up. So I wanted something simpler. Let's open up this 04 version. This solids one is basically just the same speed test as we did before. So what I ended up doing in here was something basically like a constant. I'm calling it that because it's data that can't really be keyframed. So it kind of acts like a constant in programming. And as you can see, what I've done here is I made a slider control, but I named it with all of our points. So this slider that we're using as a constant, it's going to be where you're going to put those ordered null lists to build each polygon. So every layer has one of these, and each one builds a separate polygon. That way we only have one thing to look at, and I can still easily reference it because it's basically just the first effect on the layer, and I have all my data. It takes the whole loop down to one command, and it just simplifies things. So I'll show you how that works in a little bit. First, I want to show you that you can also do this with actual like polygon looking things. So these are the actual shape layers masked out. This is just a quick thing I was messing with, so that's why it's kind of funky looking. It's also that way because these are all added in front of each other. The line variant is a little easier to do because if you want to actually calculate like some sort of occlusion, I'm not sure how you would do that without making like an actual like ray tracing engine. I mean, we're basically building an engine in After Effects, which is pretty cool, but going that far is a little too much complexity. So let's go in here and check out one other set of models that I built. So I made this icosahedron in Cinema and basically did the same thing that we were doing before. So then I just have a few different versions in here so I can do different things with them. So I have one that's clean. This one has like nothing behind it. This one has no glow or anything. I also made this glitch version. If you remember that our constant is basically a renamed slider, I'm also using that slider to set up an offset. That way we can kind of glitch it by selecting different nulls to build our shape from. So if you see here, it kind of pops in, and later on we'll see an example of how you can actually morph with that. So then I tried to go for speed, and I made a version that doesn't use Saber. So I basically got it as close as I could without spending too much time on it. If you need speed and you want to get close, this is the best way to do it. So now is when we're going to check out our expressions. So let's hit EE on this guy, and we're going to load up this path up into Expressionist. Bring that over here. This expression, as well as the project file, will be in the project link below. So in our first line, we're going to set points equal to effect 1. I still don't know why, but After Effects numbers the effects from 1, not 0, which is a fact I forgot like 5 times while building this. And then we're going to get .name, .split, and inside of 2 single quotes, we have a comma. So what this does is take the name string of this effect, and then splits that string by the commas. So it dumps out the commas and gives us an array of the numbers that we have left. So then I'm going to set up a variable called offset. And if you remember, our nulls in Cinema start with 0, but our layers in After Effects start with 1. Since I want to be able to take a list of nulls right out of Cinema and then just put them right into After Effects, this one is going to make sure that when I put in 0, I actually get layer 1. Or if I put in null 7, I get layer 8. And then to that, we're going to add the value of that first slider. And that's so we can do that offset thing where we pick different nulls to build our shapes. So then we're going to set p equal to a new array, and we're going to loop through those points values. I'm going to do a for loop, setting I equal to 0, while I is less than points.length. We're going to do I++. So we're going to start a loop at 0, and every time through the loop, we're going to add 1 to I. Then we're going to set j equal to points I plus offset. So remember, points is an array of our nulls by their layer number. So we're taking that layer number and adding our offset. It's going to at least be 1, because again, the difference between our layer number and our null number is 1. And points I needs to be put into parse int, because even though this is a number, it's really a string, and so it needs to be converted into a number for this addition to work. Otherwise, in this case, say we're on the first one, which is 2. If you add that 1 to it, it would be 21 and not 3. So we need both of these things to be treated like a number. So then onto P, we're going to push a value, and we're going to wrap that in from comp to surface. That's basically going to take our 3D point that we have and convert it into a 2D point. Without that, you have to take a value and split it off into X and Y and dump the Z value and then save that. So this was easier. And into that, we're going to put this comp.layer J. Remember, J is now our layer number. That's properly offset, so we get the correct null. And then we're going to do .toComp000. So what this does is take our layer's position and takes its 3D value and figures out where that would be in our 2D comp. So when we're done with this loop, we have an array of our converted XY positions of all of our 3D points. Then in our last line, we're checking if we have our open checkbox checked. And if we do, we're going to do this create path. Otherwise, we're going to do this create path. And the reason we do that is that by default, create path will relink back to the beginning. So this line would go from null 2 to 3 to 11 and then back to 2. But if for some reason, and let's actually go back here real quick, you might want like an edge like this to not light up when the whole shape is lit up. So instead of closing this whole top shape in, I have it set to open so we only get this line up to here. So the transparency of this one is handled by the side polygon at the top. So that's why you would want to do that. So to do that, we have to pass a couple of extra things to create path. These are for like tangents and things that we don't have. So we're just passing null arrays. So it's P, open close bracket, false. False, as you might have guessed, tells it to keep that path open. And that is it for building the actual path. So this slider is just linked to another slider in a controller, just so we can offset all of these paths by whatever number at one time to do that glitch thing. So that's just a direct connection if you want to do that. So let's handle our normals. Let's open up our opacity expression. So you can see we're setting up the same points array by splitting our string. We're calculating the offset the same way. And down here, we're basically doing that same thing. For points 0, we're adding the offset. Points 1, we're adding the offset, and so on. To the end, I'm adding toComp000. And that's because I think if you're using a camera in here, that will affect the position of those nulls. We might need that to get a correct normal for our comp. So then after we set up all 3 of those points, we're going to set n equal to calculate normal, 0.1, 0.2, 0.3. And calculate normal is a function I made. So here we have a function declaration for calculate normal, and we're going to give it 0.1, 0.2, 0.3. These are just some notes on how to calculate a normal. What we need is the vector component that points in the z direction. Whether that's positive or negative, that tells us which direction our layer is facing. So this is just some notes about calculating the vector. So what we really need is the z component of the vector. But to get that, we have to calculate the whole normal anyway. So we need to grab the cross product of the vectors drawn between 0.1 and 0.2 and 0.1 and 0.3. That'll give us our normal. Usually we use u and v for that, so I set it up the same exact way. So here we have our x component, our y component, and our z component. And to get these lines, we're basically subtracting one from the other. So this is 0.2's x minus 0.1's x. 0.2's y minus 0.1's y, and 0.2's z minus 0.1's z. We do the same thing for v, except we're just subtracting 0.1 from 0.3. And there's already a cross product function. So our function is going to return the cross product of u and v. That's going to give us a normal with what they call ijk, I believe. But it's really the x, the y, and the z component of the normal. That's not a position, that's a vector. I'm going to jump into Cinema real quick to show how we're going to use that. So on this model, this blue part is basically what we're calculating. As you can see, it sticks out perpendicular from the face. So that would be our surface normal. So the vector, which is basically the line that this is pointing toward, has an x, y, and z component. So you can see here we're pointing a little up, so it has a little bit of a y component and has a little bit of z component. And in this case, it's flat to the thing, so it has no x component. If this thing was rotated like this, it would have an x component. I'm going to undo that. So what we're interested in is how much this is pointing in z. Because in our 2D plane camera, that's going to tell us which portion is facing us or if it's facing away. If there's any bit of z that's negative, this is facing the other direction. So that's what we're going to do in the next couple of lines. First, we're going to set up a variable called f, and that's going to be whether or not we're going to flip. I want to be able to just multiply by this number. So instead of getting a 0 and a 1, like our checkbox would normally get, I want a 1 if we're going to leave it alone, and a negative 1 if we want to flip it. So to do that, we put that inside of a linear function, and as it goes from 0 to 1, we're going to go from 1 to negative 1. And that's necessary because depending on what points you pick, your normal might be flipped. So let me show you why that might happen. When I started figuring out my polygons, on this particular piece, I started on this null, and then I went to this null, and then I went to this null, in the corner back here. So even though I'm still going around this polygon in this direction, the normal that's drawn by these 3 points actually goes counterclockwise when you go back to this point over here, which meant the normal calculation for this thing faced down instead of up, which flipped it. So if you're very diligent about picking your points, you might be able to avoid that, but this checkbox is here to fix that for you. So then our final line, we're checking if our z position of that normal, modified by whether or not we're flipping it, is greater than 0. This will be 100% visible. Otherwise, it'll be set to the value. And I'm using that so that we can actually control how transparent the back pieces are by changing just the transparency of this thing. So right now, if I were to turn this off, you can see it's just 25. And that's how we calculate the normal and get our pieces faded away when they're facing away. So the rest of the stuff, I was just playing with different things. This one has animated normals. So the expression is slightly different so that it animates as it goes along. It's hard to tell at this speed, but you can kind of see that this one like fades up as it gets closer to us. And then once it starts facing us, they're 100% on. I also tried that morph thing we were talking about. So let's open up a new comp. Comp 1 is fine. And then we're going to open up models. I'll grab icosahedron 2, drop it in there like we did before, scroll down in Cineware, and extract our data. Delete our camera, our other camera, the C4D file. Move our cloner down, select everything, hit A for anchor point, 0, 0, hit R for rotation, 0, tab, tab, 0, tab, tab, 0, deselect our cloner, parent everything to it, hit P for position, 960, 540 to center in our comp, select everything from the top down, and copy. Then let's go back to our morph comp. I'm going to hit Command V to paste those in. It's going to give me an error, because right now it's looking for a slider on this cloner. I'm just going to name this thing cloner 2 and that error should go away. I'm going to hide these things so I don't want to see them. Select them all, hide those. So now you notice I have the offset keyframed and it goes to 11, which is how many points we normally had. So we go from 11 points to 22 points and now it switches to a different model. If we rotate this clone with it, paste that in there, it'll keep going, but it'll be messed up, which I think is pretty cool. Obviously you can morph it to something better. And since these all have their own slider, you can morph to a shape that has more points if you really wanted to. So one thing to note, if you're going to use the Saber version of this, you're going to have to set up your shape just a little bit differently. Normally I just double click and get a rectangle and make sure that it has a fill, and then we'd be ready to go. If I hit UU on this thing, you can see that I've changed the rectangle here to be 96540. This is normally 0, 0 by default. And it's important that you change this stuff because otherwise the shape will be in a different spot. I think there is an earlier version I did in here where I didn't change that, and we use a different version of the expression. But the version of the expression that I showed in here is the most efficient version. And I believe we also have the anchor point changed. I think the anchor point is also 0, 0 by default, so it needs to be 96540 as well. All right, and the last thing I'm going to show you is how I built the non-saber glow. I'm using set matte with saturation on here to grab just what's saturated. I'm using a Gaussian blur with 5. Then I'm solid compositing it here. You can do the solid composite first, and you're going to have a different value for your Gaussian blur. But it seemed to look a little bit better this way, so I went with it that way. And then we just have some various glows. You're going to have to play with this based on whatever you have set for your shapes. But here I have a low threshold, a decently high radius, and a lower than normal intensity. The second one has a little bit higher threshold, a way higher radius, and a little bit less intensity. And then the third one has a higher threshold again, an even higher radius, and the same intensity. After that, I have a hue saturation, just bringing the hue back 15 degrees, because otherwise it was getting a little too green-yellow, and I didn't want that. So that's it. Hopefully that's action-packed and informative. I have some ideas on how to do this with a CSV, so I might work on that and bring out another tutorial based on that. But that's it. If you guys have any comments or questions, leave them in the comments down below. And if you'd like to help support what we do, check out patreon.com/workbench. Make sure you keep up with the blog at workbench.tv. And as always, we are Joe and Sev, and we'll see you next week. Bye.